Okay, so let's shift things up a little bit. We're going to look at balancing equations which have polyatomic compounds in, polyatomic ionic compounds. Remember, the polyatomic ions were the ions with lots of atoms in them on the back page in your reference materials. So, for example, we've got a carbonate is a common one, found in limestone, or hydroxide found in bases. Nitrate, very common. I've put R3Cs just as a reminder here. And let's look at our equation. First of all, let's find those polyatomic ions and highlight them. So we've got our nitrate, NO3. And what else we got? We've got a phosphate, PO4. Now you see we've got a lot of O's in there. We got 3 oxygens in that, 4 oxygens in that. That's 7 oxygens all mixed up together. Life's going to get pretty complicated if, when we balance it, we break it right down into individual elements. So we're going to keep our polyatomic ions together. So let's start at the top of our 3Cs and write out the equation nice and big. We've got AgNO3 plus K3PO4 makes Ag3PO4 plus KNO3. Now we'll add our placeholders. Draw a line under the arrow. And let's list our elements, but this time we're not going to list N and O separately, we're going to count NO3 and K, and we're going to count the PO4s. So then we're going to write them out in the same way over here. Do you see how much space we need? Don't try and do it too small, it's difficult. Okay, so now we can count. We've got 1 silver, 1 Ag. Now NO3, we've got 1 NO3. Ks, we've got 3. And we've got 1 PO4. Over here we've got 3 silvers. We've got 1 NO3. Got 1 potassium and 1 phosphate. So we look at this and we say, ooh, we've counted, now we're checking, and it's not balanced. We need 3 silvers. We've got 3 on this side, only 1 this side. So let's put a 3 up here. We've changed it, so we count again. Now we've got 3 silvers, and we've got how many NO3s? We had 1. Now we've got 3 times as many. We've got 3 NO3s now. The potassium stayed the same and the phosphate stayed the same. So, now we check it again. We've got 3 and 3 now. But now we've got 3 of these and only 1 nitrate on this side. That's no good. So we need more NO3. We need 3 NO3s. Well, let's put a 3 here. Now we count again. So now how many potassiums do we have? We had 1. We've now got 3 times as many. So we've got 3 potassiums and 3 NO3s. So now it's balanced. Before you go off and do your own, if we'd had magnesium nitrate, MgNO3, and we had to count our magnesiums and our nitrates, we'd say we've got 1 magnesium, and NO3s, we've got 2. Remember, the subscript multiplies how many's inside, so we've got 2 NO3s. Oops, wrong color. 2 NO3s. Oops. Oh dear. What have I just done? I'm sorry, I've made a mistake. Now, you can move on to your next page, and you've got one to do here. Remember, we've got SO4s, SO4s. We've got hydroxides on both sides. How many SO4s do we have? We've got 3. And I'm going to leave you to try it on your own. When you've finished, unpause the machine. Okay, so press pause now and try and solve that equation on your own. Welcome back. I hope that went well for you. Let's do our 3 C's and balance this equation. So we start out by writing it out big. Need lots of space for this one because it's a big equation. Okay, we add our placeholders. A line under the arrow. And now we're going to break it down into its elements, and well, into its ions, really. So let's see, we've got Al, we've got SO4, we've got Ca, and we've got OH. I'm going to write it in the same order on this side because it's so much easier to keep track of things. Okay, let's change color. Now, let's count. Aluminum, we've got 1. SO4, we've got 3 of them. Calcium, we've got 1. Hydroxide, we've got 2. On this side, we've got 1 aluminum. We've got SO4, we've got 1 SO4. 1 calcium. OH, we've got 3 of them. Okay, so we've counted, now we check it. Is it balanced? We've got 1, 1, that's good. 3 SO4s, 1 SO4. Whoops. So let's fix that. Let's put a 3 up here. Multiply that CaSO4 by 3. So now we've got 3 calciums and 3 SO4s. Okay. So now we check it again. 1, 1, 3, 3. That's good. 1, 3. That's not good. So we need oh, I made a mistake. I made a mistake. Look at that. There should be a 2 there. You see? A 2. You got to be careful on these things or else you can get very mixed up. Alright, let's carry on. Oh wait, that means that's a 2. Okay. Let's carry on. Where were we? We were checking. Well, I guess we could fix the aluminum now. We got 2 aluminums, 1 aluminum. Let's put a 2 up here. Now we got 2 aluminums. And we had 3 OHs. We've got twice as many now, so we got 6 OHs. Okay, so we're looking better here. We got 2, 2, 3, 3, 1, 3. So we need to fix this 1. Turn it into a 3. So we'll have 3 of those. Now we count. We've got 3 calciums. And there's 2 OHs in each calcium hydroxide. We've got 3, so we multiply it by 3. So now we've got 6 OHs. So we've got 2, 2, 3, 3, 3, 3, 6, 6. Now it's balanced. Very good, folks. I've given you a set of practice problems. If you get stuck, remember you can come back and look at the videos.